Hello everyone, we're Ashton Hunt, Andrew Wilhelm, and Michael Wadley, and together we make up Dino3Harris. Before we dive in, let's give you a bit of context to our project. We're sponsored by L3Harris, an aerospace and defense contractor that provides a wide range of advanced technical solutions to government partners, and our focus today is on their communication systems. L3Harris needs to rigorously test these critical systems, and one of their most effective tools is called the Network Traffic Generator, or NTG for short. These NTGs simulate a wide variety of network traffic, enabling comprehensive testing for efficiency, data integrity, functionality, and security. However, there's no one-size-fits-all NTG, so the engineers at L3Harris need to use multiple tools to meet specific testing needs. Here's the problem. Each NTG works differently, meaning engineers must learn and use a different interface for each one. On top of that, many lack key features like data interpretation, which turns raw numbers into something understandable and actionable. As a result, engineers spend a lot of time diving into these complicated systems, navigating clunky interfaces, and manually processing data, all of which slows down the testing process. That's where our product, DinoGlue, comes in. We serve as the bridge that allows engineers to interact with a variety of NTGs, like T-Rex and Ixia, all through a single comprehensive suite. In addition, we provide features like automatic data processing and visualization, making engineers' jobs easier and more efficient. Welcome to the front page of DinoGlue. Here, we have a dashboard for all the statistics about DinoGlue itself, as well as some quick action buttons for added convenience. Our first stop would be the Instances tab, where L3Harris engineers can connect to any NTG instance they so please. Let's put ourselves in their shoes for a minute and say that we have a device we want to test. We've connected it to a network traffic generator in lab number 5. This is a T-Rex network traffic generator. So now on the Instances tab, I give it an appropriate name, I tell it the type of network traffic generator that we're working with, and I just put in all the other information I need to connect to that hardware network traffic generator device. All these other fields are optional, but we can see by hovering over the tooltips what those fields are all about. Now that we click connect, we're connected to our instance, and we could start all of our other work from here. Now that we're connected to an instance, we can run some network traffic, and that's where the concept of profiles come in. Put simply, profiles are a list of streams that allow us to dictate what that traffic is going to look like and what it's going to do. I could create a new profile, or I could come over to the profiles that my coworkers have made that fit our needs. In this basic traffic profile, we can see the list of streams that we have, add and delete them as we please, and modify all the fields relative to each stream. On the basic editor, we can change this to, say, a burst test, come over to our advanced editor, and see that that change has been made. This advanced editor is for our more experienced users and is robust, so if I put in some bad data, DinoGlue will catch that and it won't let us save or run this bad profile. I'm going to change it back to a continuous test now and see that my configuration has been saved and it's reflected back on the basic editor. Now we're all good to go, so we could start this profile, select our instance, and encounter our first warning that simply says, oh, we don't want to run on multiple ports for this second stream. We provide users with an easy way to handle these warnings, so with this port issue, we simply deselect a port on stream 2, and that's all there is to it. If we want to schedule this test for any time in the future, we can, but for now, we're just going to run the test as is right now. To do that, we now click Start Profile and see that it started successfully. We can see what profile we are running, where we're running it, and when it started. And this is super convenient for our users as they can coordinate with their coworkers on resource usage. Now for the important part. DinoGlue provides a suite for gathering and visualizing data in real time. Coming over to our port statistics, we can change all we want about this. We can gather every 5 seconds. We could even zoom in on the data to see what's going on in fine detail. If we wanted to revert that back, we certainly could. We could even, at request of our users, export this data into a CSV. If we wanted to learn more info about our test, we could go up here. We could even stop that test from this page, which we'll do right now. Coming back over to our test execution page, we can see that the test is completed. We have its ID, profile, all that useful information, and going back to statistics, we could see them in the future and do the same exact things, looking at how it ran over time, export that data, so on and so forth. At its core, DinoGlue provides users with a powerful application programming interface, or API for short. This just means that we've given them a framework for interfacing with all of the functionality that DinoGlue has to offer in their own terms. Things like profile management, interfacing with network traffic generators and their functionalities, running tests, collecting test data, so on and so forth. To learn more about it, they can come to our API documentation page and see all of these functionalities for themselves, or API endpoints. If they wanted to learn more about a specific one, all they need to do is click on it, and they could even try it out in our website. Now that we've gone over the basics of DinoGlue, we can disconnect from this T-Rex instance, and if we were an L3Harris engineer, we'd have just saved hours of work by using DinoGlue. DinoGlue is a high-performance API built entirely in Rust, enabling efficient load balancing, thread management, and robust error handling while interfacing with network traffic generator APIs. We use a timescale database to aggregate and store collected data over time, and for in-depth analysis, we've integrated a tool called Grafana, which we've configured to process the data and present it in a way that's meaningful and actionable for the engineers. The entire project is containerized with Docker. Combined with its efficiency, this enables streamlined deployment across any system where L3Harris will need it. Over 32 weeks, we completed 93 different issues, merged in over 66 formal features, and wrote over 30,000 lines of code. However, we wrote our code in a modular and scalable fashion, meaning that if L3Harris engineers wanted to add in a new network traffic generator, the code changes would be minimal. This allowed us to create 17 API endpoints and 20 API data schemas, which we showed off on our Swagger page in our demo. We worked very closely with 3 engineers from L3Harris communications team to provide continual insights of their workflows, help guide us through more advanced network configuration and testing techniques, and to help us understand what features we could add that would benefit them the most. And with that, we've created a comprehensive all-in-one suite for L3Harris engineers to interface with network testing tools, saving them countless hours for years to come.